Welcome to solverfy.
All right, so we've got a couple or a few epoxides. One simple epoxide, basically the most simple epoxide you can have, but with a methyl group sticking off. You draw that a little better. Okay, that's A. And what I would say is that they mentioned that there are two ways to name that, and that's because epoxides can be named as oxiranes, right? Or they could be named as oxides of alkenes. Okay. So what is meant by oxirane is that we assume that the base unit is the oxygen-containing ring, and then we just name whatever is sticking off of it, with the assumption that the numbering will be such that whatever is sticking off of it has the highest number instead of usually the lowest number when we think about substituents, right? So if we consider this to be an oxirane, then what is sticking off of it is a methyl group, and if we follow the rule that we need to indicate the numbering then on which this methyl is being sticking off, we would say 1, 2, right? So that becomes 2-methyl oxirane. Okay. The other way we can name this is an epoxide of an alkene. So what we do is imagine, well, instead of this carbon and this carbon having a bond to an oxygen, we think, what if they were bonded together? What would we'd have? We'd have something that looks like this, right? So that would be like propylene, right? 1, 2, 3 carbon chain propyl, but it's an alkene, that's propylene. Okay. And then we take whatever the name of that alkene would be, in this case propylene, and we just throw oxide on the end of it to indicate, well, we don't actually have a double bond. We have 2 bonds to oxygen, right? So we'd say propylene oxide. Okay. That's the 2 ways that we could name B. So now let's look then at A. If we look instead at B, we'll see that this alkene way of naming it, where we consider the analogous alkene and then name it as such, it's going to be pretty nice, right? Because we could consider, okay, this is our molecule. What would the analogous alkene look like? It would look like this, just a substituted cyclohexene, right? It would be a 1-methyl cyclohexene. Okay. Well, what's the rule? We just name what the alkene would be and throw oxide at the end, right? We say 1-methyl cyclohexene oxide. 1-methyl cyclohexene oxide. Not too bad. Okay, and our final epoxide C is going to be somewhat similar to the first, right? We're given, right, we can think of this as being our oxirane, carbon 1, carbon 2, carbon 3. Our carbon, let's see, think about this alphabetically. Methyl comes before propyl, so we would want our methyl on 2, and our propyl group 1, 2, 3 on 3. Okay. So really what we have is an oxirane, just like we did before. We think about the oxirane unit with a methyl group sticking off of carbon 2 and a propyl group sticking off of carbon 3. Okay. So ultimately we would call this 2-methyl 3 propyl ox, ear, okay. Next, then, would be the way of naming it like an alkene. We think about what that alkene would look like, right? Here we've got 1, 2, 3, 4, 5, 6 carbon chains. That's a hexene. The alkene, we want to give the lowest possible numbering, so that's a 2 alkene, so hex 2-ene, right? So we could call this hex 2-ene oxide. And we'll note that both of these are going down as opposed to going up. So this is going to be a cis hexene oxide.